Hello everyone, I'm Nianlong from Institute of Software, Chinese Academy of Sciences. Today I'm going to give a presentation of my paper, vMirror, enhancing the interaction with occluded or distant objects in VR with virtual mirrors. Interacting with out-of-reach or occluded objects can be cumbersome in virtual reality. Although users can change their position and orientation, such as via teleporting, to help observe and select. Doing so frequently may cause loss of spatial orientation and motion sickness. In our life, it is intuitive and natural to use mirrors to observe. For example, we look in the mirror to make up, observe the rearview mirror while driving, check the teeth by the dentist with dental mirror. Therefore, we present vMirror, an interactive widget leveraging reflection of mirrors to observe and select distant or occluded objects in VR. To understand how to place a mirror and adjust it, we designed a formative study. We use the building blocks task. Two methods for placing the mirror were tested. First is the manual approach. Participants press a button to create a mirror facing themselves. The properties of the mirror can be adjusted via the controller. Another one is the semi-automatic approach. Participants select an object center, then choose a direction to place the mirror. The system calculates the best mirror orientation, enabling the participant to see the object according to the law of reflection. Results show that 7 participants preferred semi-automatic placement because it required less operations and matched their needs. Participants also said that it was cumbersome to adjust the mirror by pressing the button. Based on the feedback, we adopted the semi-automatic mirror approach and replaced the button-based interface with motion gestures. Then we conducted the second study to examine the target selection performance with mirrors at different orientations. We adopted the standard reciprocal selection test. We designed 2 sessions, the direct target selection and target selection with vMirror. For the target selection with vMirror, a within-subject design with 3 factors was used, including mirror position, target size, and target distance. Participants were the same as Study 1. We measured selection time, error rates, and subjective feedback. Results show that the most efficient position to place the mirror was the inclined top. We also found that vMirror could be as efficient as direct select, even though having higher error rates. This may be because objects appearing smaller and distorted in vMirror. In the third study, we further investigate how vMirror would assist users with the navigation and target selection task in VR. The task of the game was to find a red gem in the ruins of stones and trees. We used the within-subject design with 2 factors, input techniques and scene range. 12 participants were recruited. We measured the user's completion time, number of teleport, change of the orientation angle, perceived usability, and motion sickness. Results show that teleport plus vMirror was significantly faster than teleport and needed significantly fewer times of teleport and orientation change. Moreover, it induced significantly less motion sickness. Future work can investigate ways of using vMirror to observe partially occluded objects and compare it with other techniques. It is worth exploring automatic strategies and combine vMirror with bimanual operations to further improve user experience. Placing more than 1 mirror might provide additional benefits. Other shaped mirrors may ensure VR interactions than a plain mirror. In conclusion, we presented vMirror, an interactive widget using mirror to alleviate occlusion and dwarf issues with recasting techniques in VR. We conducted 2 studies that refined the design choices of vMirror and evaluated its impact on target selection. We conducted a comparative study that showed vMirror was able to significantly improve teleport technique in a VR target searching task. We believed that future work could continue to explore other types of virtual mirrors to further enhance interactions in VR. This is my report. If you have any questions, please contact my email. Thank you.